Okay, guys, let's look at the big quiz. I'm assuming you want me to go over number 1.
Yes.
Yes, okay.
Please.
All right. All right, you have to be able to recognize that this is saying cosine of A minus B. This inverse sine of negative 5/13, that's just an angle. Inverse tangent of 3/4 is another angle. I'm calling them A and B. You can call them whatever you want. Okay? So you have to recognize that. And then you have to know your formula.
Do we get a formula?
You do not. Cosine A, cosine B plus sine A, sine B. All right, that's somewhere in your memory, right?
Yes.
Okay. Then, well, we need to know what cosine A, cosine B, all of that stuff is. So we have to draw 2 triangles. Now, it's inverse sine. You only have 2 options for where you could draw your triangle because it's inverse sine. What are those 2 quadrants that it could be in? First and fourth. Guys, remember it was like half the circle when we did inverse? I know this was before break. It's in your brain. Yeah, inverse sine was the right half of the circle. Since it's negative 5/13, what do you think? First or fourth? Fourth, right? Negative. It's got to be down there. So I'm going to draw a little triangle here. Call it A. Opposite would be negative 5, hypotenuse 13, and that makes the other leg 12. Okay. B was inverse tangent, which is also that right side of the circle. So first or fourth quadrant, what do you think for tangent? First, because it was positive, okay? So that's where B goes. Opposite over adjacent, which makes your hypotenuse 5. Okay, so then it's just a matter of filling these in. So cosine of A, that's 12 over 13. Cosine of B is 4 over 5. Sine of A is negative 5 over 13. Sine of B is 3 over 5. Are we okay at that point, guys? Like, you're good with where those are all coming from? Okay. Then it's just multiplying. So 12 times 4 is 48 over 65 plus negative 15 over 65. And that's where we're getting 33 over 65. Okay. So just a little refresher on the inverse stuff. Terrible line. Just remember when we're talking this side of the circle, that was for inverse sine, inverse tangent, and inverse cosecant. And remember it went from negative pi over 2 to positive pi over 2. And then this part of the circle from 0 to pi, that's if we were doing inverse cosine, inverse cotangent, or inverse secant. Okay, remember that stuff? I know it's been a long time since we've done any of the inverses. Okay. I did actually open up just an optional, another math space practice 5-1, just so you could do it again in case you've already done the second attempt and you want just a little more like, ooh, it's been a long time since 5-1, so that is there for you, okay? All right, questions on number 1? All right. Number 2, give all solutions. This is where you have to leave the K or the N, depending on which format you're using in your answer. So for 2, we get pi over 9 plus 2 pi k over 3, and 5 pi over 9 plus 2 pi k over 3. And then for 3, since it says solve 0 to 2 pi, you actually have to do the fraction addition and find all 6 of those answers. So 4 pi over 9, 5 pi over 9, 10 pi over 9, 11 pi over 9, 16 pi over 9, and 17 pi over 9. They do not have to be in that order.
For the question after 3, will they all have the same computer?
Sometimes they'll reduce. Like you may get like, I don't know.
But it would always have the same computer size.
Well, yeah, you'd be adding the same thing, and if you're, I'm trying to think of an example where they wouldn't be. No, because you'd be dealing with like a sign of something equals this. It's going to be 2 different over 3s or 2 different over 6s, that sort of thing. Yeah. Questions on 2 or 3? Go through 2. Okay, so I divide by 2 first. And then off to the side here, I just kind of think about, okay, what I'm really evaluating is just when does cosine equal 1/2? So where does that happen? Okay, pi over 3, and where's the other one? Yep, good. So then I have to come back to this side, and instead of theta, what I'm really looking at is 3x. And it's going to equal that pi over 3 plus 2 pi k and 5 pi over 3 plus 2 pi k. I'm not going to have a k in my answer. Oh, actually, on this one I am. Never mind. Sorry. I was thinking I was on 3. So then your last step is just divide by 3, and you're done. Does that make sense? Okay. All right. Are we okay on 3 or question?
I usually include K in your answer.
Because so this one says all solutions. This one only says between 0 and 2 pi. If I include the k, I'm going beyond 2 pi by a lot. So you use the same process to figure out, like, what am I adding every time, but then the k isn't in your answers either. Okay? All right, then let's look at number 4 down here. All right, guys, how do we do on 4? Anybody need me to walk you through that one? Really, it's that first step, recognizing your substitution. And the reason you should think to do that substitution is because it's tricky if you have a sine and a cosine in your equation. Every once in a while it works out okay, but a lot of times you need to substitute to eliminate one of those. Yeah?
Did you go over the trick where you know when you solutions do I have?
So this one, since there's no coefficients on the thetas, there's no like trick for that. It's questions like this one where I have a 3 as a coefficient. Normally, I would have gotten 2 answers, like for where sine equals negative root 3 over 2. So I take that number of answers times the coefficient on the angle.
Okay.
So that's how I knew 6 answers for that one. Okay. Other questions on the front, guys? Scroll back down in case you need it. Okay. Okay. All right, let's flip over and look at the back. Guys, number 5, biggest mistake there is to divide by tangent right away. If you do that, you've eliminated, well, in this one, all of your solutions, okay? So you don't want to divide away something that has a variable in it, okay? You're going to lose solutions by doing that. So you just want to subtract it to the other side and then factor and then go from there. And then number 6, again, it's recognizing a double angle formula there. Sine of 2b, that's the same as 2 sine b cosine b. And then you can factor and solve. All right, guys, questions on 5 or 6? People still writing, we'll wait a sec. It makes sense now, right? Yeah, of course. All right, we'll go down to the lovely true and false. It was true, true, false. How do we do on those? Bad? Your guessing skills did not come through for you? Okay. Sure. Guys, just want to make sure, is everybody okay at 7? That one was just evaluating, so hopefully that one wasn't too bad. 8 and 9 are a little bit tricky. So let's look at 8. So what is the period of cotangent? Do you remember, Kate? Yes. So if I've got cotangent of 2, even though I don't know what 2 is, adding pi to it is going to take me to an equivalent spot because the period's pi. So that's one way you can think about it. But if you're like, well, but I'm really uncomfortable with not knowing what cotangent of 2 is, then you can just, like, let's try it with something else in there. Like, what if I did, instead of 2, I said pi over 4. What is the cotangent of pi over 4? 1. And then cotangent of pi plus pi over 4, do you see how that'd just be third quadrant? And so also 1. Okay, so that's why that one's true. All right. Are we okay on 8? Does they make you think a little bit? I know we need to talk about 9. Are we okay on 8 though? Okay, let's look at 9. Part of 9 is recognizing the difference between cosine and inverse cosine. What I have written above there in the red box, if it had been written that way, cosine of x equals cosine of x plus 2 pi, that is absolutely true. Okay, the period of cosine is 2 pi, you're just talking about traveling around. But it says inverse cosine instead. So that's why this one is false. Again, we could think of something like with a value we actually could do. I could take inverse cosine of root 2 over 2. What would that equal? What is the... Yeah, good. What angle has that cosine? But if I tried to plug that same value in on the other side, the root 2 over 2, do you guys see how that doesn't make any sense? Root 2 over 2 plus 2 pi. You're talking about an angle, and then you're talking about one of the ratios on the outside of the circle. You're not going to be adding those two together, and the inverse cosine of that is definitely not going to just be pi over 4. Okay? Just remember, like, I can do cosine of an angle, right? The angle's in there, and then I get some sort of ratio over here. When you do the inverse, you're switching it around. The ratio's now in there, and what you get is the angle. Okay? Cosine, inverse cosine, they are different. All right? Yep.
So what you wrote in the box, that would be true?
That one would be true, yes. This one is true. Do you see how it's different? Okay. I know, it makes your brain hurt a little.
Oh.
Yeah. It's like really understanding the difference between the cosine and the inverse cosine there. Okay, guys. So that's your whole fake quiz. There is the Delta Math review, the required one that is up. Second attempts for all your homework's all up. The extra attempt on 5-1 just for practice is there. And guys, remember, on Schoology, there's all sorts of extra review materials for you there as well. Next week, I know it's not time for class to end, but that's what you got to work on. And then next week, Wednesday, is Religious Observance Day, so we'll just talk course recommendations. I did post the little math flow chart for you guys on Schoology, a link to that if you wanted to look at that a little more closely. And then your test is the following Tuesday. 11 days from now, you'll finally have a test.